So let's solve problem 1.2 of Irodov. So point traversed half the distance. So first they play with the distance with the velocity v naught. Okay, this is basically like the magnitude of the velocity. The remaining part of the distance. So half the distance is already traversed. The remaining part of the distance is the remaining half of the distance was covered with velocity v1. Okay, so now the velocity has changed to v1 for half the time. So now they're playing with time. So initially they were playing with distance, so half the distance v naught, and now for half the time, it is covered with velocity v1 for half the time and velocity v2 for the other half of the time. Okay, very well. So find the mean velocity of the point averaged over the whole time of motion. Fine. So like just a small thing, mean velocity basically is the magnitude of the mean velocity is basically the the total displacement over the total time. uh, so the displacement over here is, so obviously the point is, so we will assume without loss of generality that the point is basically moving in the same direction. So it's basically it will just help us to make the problem easier. So it's basically like the total distance divided by the total time taken. That's it, as simple as that. We need to find the mean velocity with respect to only these three velocities, v0, v1 and v2. That's the thing. All right, so let's say our total distance was d, and just reduce the thickness. Yeah, so the total distance, let's say, was d, capital D, and let's say, so okay, so let's take that distance for now. Fine. So what they're saying is half the distance, that is d by 2, basically is speed into time. So initial half of the distance is v naught into, so the time taken for that covering that half the distance, let's consider it to be t1. Okay, let's assume that the time is t1. Fine. So this is for the first half of the distance. Now the remaining part of the distance, which is obviously again another d by 2, that was covered with a velocity v1 for half the time and with velocity v2 for other half of the time. Okay, so basically let's say t2 is the time taken for covering remaining d by 2, right? So again, so if we consider again d by 2, right? So for half the time there is one velocity, and for half the time there is the v2, the other velocity. So for one half of the time, so it is v1 into t2 by 2 plus v2 into t2 by 2. It's as simple as that. Okay, so basically you just cancel out these twos simply. So over here, so basically what we need to find out, so this is what we need to find out finally what we need to find out is this quantity d, that is the total distance divided by the total time. So total time is obviously t1 is the this time taken for the initial half. T2 is the time taken for the remaining half. So T1 plus T2. I'll just circle it in some other color. I mean, just mark it in some other color. All right. This is the quantity that we are looking for. All right. So basically, we can do it very simply. So yeah. So yeah. Basically, what we do is okay. So D is 2 V naught T1. Fine. Right. Uh, Divided by T1 plus T2. Okay, good. But now we need to write T2 in terms of T1 or T1 in terms of T2, so that in terms of V1 and V2. So V0, V1 and V2, so that these terms are not there, because we need to find the mean velocity with respect to only V0, V1 and V2 that are given in the question. Okay, so this basically, so we'll just number this. All right. So this basically came from equation 1. This thing came from equation 1. I mean the numerator came from equation 1. Fine. Now what we can do in order to like eliminate this T1 T2, I'll just write it separately. We can equate 1 and 2. So 1 and 2, because the LHS basically you can write like D. So D is equal to 2 V naught T1, which is D over here as well, which is, so if I take T2 common, V1 plus V2 into T2. Okay, simple. So now this becomes, so okay, I'll just write, so this will be useful. So T2 by T1, just shift, yeah, shift this, so that becomes 2 V naught by V1 plus V2. All right, fine. So if we, let's number this as 3. Okay, this is, sorry, so this is 3. Okay, so if we consider this, and from 3, okay, so let's see, 2 V naught T1, sorry, 2 V naught T1 by T1 plus T2. So divide numerator and denominator by T1, 1 plus T2 by T1, right? So now basically from 3, what is T2 by T1? 2 V naught divided by 1 plus 2 V naught, sorry, 2 V naught by V1 plus V2. Fine. This becomes 2 V naught V1 plus V2 divided by V1 plus V2 plus 2 V naught. Okay, so if we, yeah, so this basically matches with, so 2 V naught V1 plus V2 by 2 V naught plus V1 plus V2. So yeah, so this is basically just a second, yeah, this is basically our mean velocity magnitude that is being asked. So this is basically the answer, and you can obviously will check it with the Irodov solutions. So the answer, 2 V naught V1 plus V2 by 2 V naught plus V1 plus V2 matches. So yeah, so basically this is how this was a, this was a simpler question. So this is how this is solved. So yeah, Thank you.